Hi guys, today we're going to be doing applications of derivatives. So this one video in particular is going to be more about motion problems. So first let's talk about how we even go about solving these. So you guys should know by now, a derivative is essentially the slope of a function or the rate of change of a function at a certain point in time. So these two lines in pink are something that you really want to hammer into your brain. So velocity is the derivative of the position function. So, what that means is basically that velocity is a measure of how quickly an object's position is changing over time. Okay? So that's why, the units might be feet per second or meters per second, something like that. Now, for acceleration, acceleration is the derivative of the velocity function. So, acceleration is measuring how fast the velocity is changing over time. So, these two you really, really, really want to remember, okay? So, like, tattoo it across your forehead. Remember these, okay? So, let's start with our first question. A particle moves in a line with position s of t equals 3t squared minus 5t plus 2. Alright, well, I'll use pink. I don't know. I'll use yellow, whatever. A. So, find v of t. Okay, the v of t is the velocity. So we just said that velocity is the derivative of the position function, and this is the position function, right? They gave us the position right here. So all we have to do is take the derivative of s of t. So v of t would be 6t minus 5. Okay, and if you're having a little bit of trouble with differentiating, then I have a video on my channel, Derivatives in 20 Minutes. You can go watch that. Or if you want something more in depth, um, I'm sure there are a lot of the Khan Academy or those types of videos out there. But let's keep going. So A of t is the acceleration. Well, we said that acceleration is the derivative of the velocity function. So A of t would just be the derivative of v of t, which would be 6. I don't like this yellow, but whatever. We'll change it next for the next slide. So the acceleration function is 6. C. Find the velocity at t equals 3. Okay, this one is easy, right? We're just going to plug 3 into the velocity function. So v of 3 equals 6 times 3 minus 5, which is 13, but 18 minus 5, which is 13. So, a particle is moving along a straight line so that its position is s of t equals t cubed minus 6t squared plus 9t. Okay, so first let's find when it moves right and left and when it speeds up and down. I'll use this blue. So first let's find the velocity function, right? So the velocity is going to be v of t would be, right, the derivative of s of t, which is 3t squared minus 12t plus 9. Now, we need to factor this. Why? Well, setting the velocity to 0 finds the turning point, so moments when the object stops and changes direction. Okay? So, let's factor this out. We could just factor out a 3, would be t squared minus 4t plus 3. And then this would eventually factor out to be t minus 1, t minus 3. Now, the reason why we factor is, let's look at a graph. Right? If I have a velocity graph, every time, so look, it's positive right now. Every time it hits 0, it's going to go back into negatives. And every time it hits 0 again, it's changing direction back into positive. So that's why we want to find the zeros of the function. Okay? So, because we want to see when it's changing direction, when the velocity is negative or when the velocity is positive. So, our zeros would be t equals 1 and t equals 3. So those are the moments when it hits the x-axis or when the velocity is the total is equal to 0. Okay? So this is something really important. We're going to do something called a sign chart. So we're going to check the sign in each region. Okay? So since we know our uh zeros are 1 and 3, we're going to make a little kind of like a little number line. So we're going to put 1, 3, and this is, you can think it's infinity and negative infinity because we know it doesn't hit 0 anywhere else. So now, the thing to remember, if the velocity is positive, then the object is moving right, and if the velocity is negative, then the the object is moving left. This is our little sign chart. You don't have to do it, but I find that it's really helpful, especially when you go back and check your work. Also, sorry, I'm a little sick today, so my voice might be a little bit off. But so anyway, we're gonna basically put in any number between negative infinity and 1 and plug it into our velocity function to see if we get a positive or negative. Well, 0, right? 0 I feel like is pretty easy. So 0, if we put 0 into v of t, we're going to get 0 minus 0 plus 9. So this is positive. Okay, now between 1 and 3, I'm going to put in a 2. So this one I'll have to write out. Write it out in red. So 3, I'm going to plug in a 2, right? Because that's between 1 and 3. So 2 squared minus 12 times 2 plus 9. And this would be 12 minus 24 plus 9. I already see this is going to be negative. Negative 12 plus 9. So this is going to be negative. Alright, so let me erase this. We're running out of space. And finally, 3 to infinity. Well, this one, you don't even really need to do anything. Like, you could put in like a billion, right? 3t squared minus 12t plus 9. You can see, obviously, if I put in a billion, this is going to be positive, right? 3 times a billion squared, like 12t and 9 don't even matter. So this is going to be positive. Okay? So now, we know that from, well, let's answer A first. So from negative infinity to 1, the particle is positive, so it's moving right. Then from 1 to 3, it's moving left because it's negative. And then from 3 to infinity, it's moving right. So question A is done. So now let's see when it's speeding up or slowing down. Now, this is important. To find out when an object is speeding up or slowing down, this is when you need to bring in acceleration. In the last problem, we didn't really need to talk about acceleration. We just found the function for it. But this time, we're gonna need to see. We're gonna need to make another sign chart. Okay. So let's just write out the acceleration function. So the acceleration function is going to be the derivative of the velocity function, which is going to be 6t minus 12. Okay. Again, we're going to do that same thing. We're going to factor it out to get the zeros because, quick little graph, it's important you really hammer this home. If this is the acceleration function, when it hits 0, it's from a positive value to a negative value. And when it hits 0 again, it's going from a negative to a positive. So every time it hits 0, it's changing the signs, okay? Okay. So now we have 6t minus 12. So let's factor this out. So this would be 6t minus 2. That means t equals 2. So when at 2 seconds, the acceleration hits 0. Okay, so let's make our sign chart for acceleration now. So a little boom, boom. Our only value is 2. So 2, and this is negative infinity to infinity. Okay. So let's put in negative infinity. This is obviously going to be negative. If we put in negative infinity, we're going to get a negative. And if we put in positive infinity, or like let's say something huge like 999 billion, we're going to get a positive. So from negative infinity to 2, the acceleration is negative. And from 2 to infinity, the acceleration is positive. Now, a lot of people make this mistake. They think when acceleration is negative, the object is slowing down. But that's not actually true. The object is slowing down when the acceleration and the velocity have different signs. The object is speeding up when the acceleration and velocity have the same sign. So let me say that again. The object is speeding up when the acceleration and the velocity have the same sign. For example, when both are negative or both are positive. Conversely, if the object is speeding down or slowing down, then the velocity and the acceleration have different signs. So one could be positive, one could be negative, or vice versa. All right. So now, let's combine both of our number lines. Okay? Let me erase this right here, because we already know our functions. Boom. Okay, so Let's combine our number lines. Okay. So first, we need to see negative infinity to 1 and negative infinity to 2. Okay. Well, let's put a. This is something I actually really struggled with because I don't know, my brain's not good with visualizing stuff. So let's just put an imaginary little 1 here. So negative infinity to 1 on this, on the acceleration. Here, this is the acceleration, and then this up here is the velocity sign chart. So on the acceleration, negative infinity to 1 is a negative, but then up here, negative infinity to 1 is positive. So that means from negative infinity to 1, the object is slowing down because it's different signs. Slowing down. Now, let's think about 1 to 2. Well, put a little 2 here. Well, 1 to 2, it's negative, and 1 to 2 is obviously negative. So from 1 to 2, it's speeding up. Right? It doesn't matter if it's negative, they're still the same sign. Now, we have 2 to 3. Well, here, let's put an imaginary little 3. 2 to 3, this is positive, right? Positive. But here, it's still negative. So from 2 to 3, it's slowing down. Slowing down. All right? And then finally, when 3 to infinity, well, 3 to infinity is positive over here, and it's also positive up here, so that means it's speeding up. So 3 to infinity, speeding up. And boom, we answered this question. We answered letter B. So the problem with these ones, especially with speeding up and slowing down, I found it really useful to kind of put in like imaginary little 2s, 1s, 3s, whatever, because I couldn't visualize where the points were in my head. Maybe you can do that, and if you can, that's great. But if you struggle with that, then I really recommend putting in these numbers, and especially using a sign chart, because I promise it's going to help you so much. All right. So now let's move on to our next question. So a particle's position is s of t equals t to the fourth minus 4t cubed plus 6t squared. Find when velocity is 0, and find whether the particle is accelerating or decelerating at those times. All right. So let's start with A. By now we should know, right? The derivative position is going to give us velocity. So let's take the derivative of this function. So v of t is going to be 4t cubed minus 12t squared plus 12t. And let's find when the velocity is 0. Well, let's factor out a 4t. It'd be t squared minus 3t plus 3. So actually, this never equals 0. So the only time velocity is going to be 0 is when t is 0. If you don't believe me, like, feel free to check it out on Desmos, plot that graph, but this quadratic will never be 0. So obviously the only time velocity will be 0 is when we plug in t to this equation. T equals 0 to that equation, sorry. Alright, so now, let's see when our particle is accelerating or decelerating. Well, let's draw a little sign chart first. So our only point to put up, our only point to put up here is 0. So negative infinity, infinity. So if I put in infinity over here, I'm obviously going to get a positive, right? If I put like 100 billion into 4t cubed, it's going to be so much bigger than 12t squared and 12t, all right? Same goes for negative 100 billion. This is going to be a negative. All right. So now this is my sign chart. So now let's find our acceleration function. So, because it wants to know when the particle is accelerating or decelerating. So, how do we get our acceleration? Well, it's just the derivative of the velocity function. So that would be a of t equals derivative of this would be 12t squared minus 24t plus 12. So this is our acceleration function. So we can factor this out again. 12t squared minus 2t plus 2 plus 1, sorry. So now we have our little our acceleration function. So it's asking whether the particle is accelerating or decelerating at those times. So at the time when the velocity is 0, we said that t equals 0. We didn't really need to do our sign graph, but still good practice. So let's plug it in and see if the particle is positive or negative. So if I plug in 0 here, I'd get 12 times 0 minus 0 plus 1. And this is going to be 12, which means it's a positive number, which means the particle is accelerating. So B, I don't really have space. I'll just write here. So B accelerating, right? It's accelerating because the velocity is at 0 at time 0, and the acceleration is a positive number. All right. So let's move on to the next question. All right. This is gonna take a little bit of more of derivative work. So a car has position e to the 0.5 t. All right, so let's find the velocity. So the velocity of the derivative of e to the 0.5 t is just going to be 1 half e to the 0.5 t by using chain rule. And then b, the acceleration function, would be the derivative of the velocity function, would just be 1/4 e to the 0.5 t. All right, and then finally, when velocity is 10, so that means when I put in 10, I would get, well, let's plug this in. E to the 0.5 times 10, which would equal 1 half e to the, what is this, 5? So this would be around 5.99, but really you can just keep it like this. 1 half e to the 5th. So that's our velocity when time is at 10 seconds, or whatever measure of time they're using. All right. So that's it for today's video. Thank you guys so much for watching. By the time this comes out, it should be around Thanksgiving. So happy Thanksgiving. I hope you all have a great holiday week. Thank you guys so much for watching. If you have any comments and questions, as always, leave them down below. I'll answer them. So yeah, thank you guys so much for watching. Take it easy. Happy Thanksgiving. Happy holidays. Yeah, see you in the next one.